Hello guys, how you doing? I'm Rahul, and today we are gonna completing the mass transfer. And if you're preparing for the GATE exam, then it's gonna be great for you. Okay, so from the beginning, you must know that there are few things we need to define earlier. So what is CI? Moles of individual component divided by volume. And what is called? It's called the concentration, right? You know what is called. So we are talking about a mixture which has suppose n components, and we are talking about the density of individual component and the concentration of individual component. Okay, so two things we have. Now we have next thing we have to define is the molar average velocity, and which is very important. So we define it by u bar, which is, what is it? Molar average velocity. Yes, u bar, which we have defined on, or we can call it u bar m. So it is molar average velocity, and how it is defined is simply like ci ui, summation of ci ui divided by summation of ci. So let's take example and understand. Suppose we have a mixture of two components, 1 and 2. Okay, so u bar m for it will be just c1 u1 plus c2 u2 divided by c1 plus c2. That's easy. Like, what is u1 and u2? So u1 and u2 are the stationary velocities of these components 1 and 2. So what will be happening that in the mixture, the component 1 will be going with u1 velocity, and component 2 will be going with u2 velocity, which is meter per second. And these are the velocities which are in the stationary frame. Okay, so stationary frame of reference. Okay, so that's how they are defined. Okay, so this is molar average velocity we have defined. Similarly, using the individual density, you can also define the mass average velocity, which is, okay, so which is summation of rho I ui, means rho 1 u1 plus rho 2 u2 upon rho 1 plus rho 2 for binary component. If more components, you can add similar like this. Okay, so this thing you have to just remember. You won't have to use every time, because we're gonna derive many formulas but based on that. So this basic thing you must know. Okay, so far so good. Now guys, we're gonna define a very important term in the mass transfer, which is the flux. Okay, so flux can be of two types, molar flux or mass flux. In mass transfer, we're gonna use the molar flux too often, so this gonna be used, this will be used many times. So this is a common flux we're gonna use. Mass transfer or mass flux is also there. So what is flux? Suppose for molar flux, it is mole per meter square second, and that means that per meter square area per second, how many moles of this component are being transferred. So if I talk about like a component A has a flux of 2 mole per meter square per second, that means per meter square area 2 moles are being transferred. And similarly for mass flux, it will be. Now we have an interesting thing. We denote the flux by the formula Ni. Okay, that's the flux. Okay, and how we gonna write it? So yes, here comes a very interesting. So Ni is our molar flux, which I told you that we often use molar flux. So whenever I'm using the word only flux, like I'm saying flux, that means I'm molar flux I'm referring. Okay, so flux is nothing but Ni, means I'm talking about the flux of ith component, and which will be Ci and Ui. So concentration of component I and Ui is velocity. So let's see what let's look at its units. So it's mole per meter cube for Ci, because that's how we define the Ci, and meter per second is the ui. So if you look at it, that it's meter cancel out, and it will become mole per meter square per second, which is unit of flux. So it's true. So remember that whenever you have like Ci into ui, it will be flux of Ni, ith component, right? It is easy. Okay, now we will move next. Now we're gonna come to a most important law of mass transfer. Okay guys, so now we have the Fick's law, and what does it say? That the molar flux of a component I, okay, with respect to molar average velocity, so it is with respect to the molar average velocity, which we have defined just here. Molar average velocity, we have defined it like, okay, you know how we have done. So if you go with this molar average velocity, then the flux will be this, okay, and z is the direction in which we are going. So if we are moving in the z direction, and there is suppose and that's how the concentration of A is changing with Z. So partial differentiation with Z into its diffusivity. So this is called as diffusivity. Okay, it is called as diffusivity. That's easy, right? Okay, so now we have this law, and we're gonna derive something. So what is with respect to molar average velocity? And so we can write it as what is saying, that Ji is nothing but Ci to ui minus u bar. That's what it's saying, that the flux of component I when it is going with respect to molar average velocity. So this is our molar average velocity, this is actual velocity, and this is concentration, and we know that concentration into velocity is flux, but because it is with respect to molar bar, molar average velocity, so it will become GI, not NI. So what is NI? NI was CI into UI. So NI was CI into UI. Okay, and now we have JI. So just do a little thing. So what we're gonna do over here? We're gonna simplify it, and we're gonna take a binary mixture. Okay, so we have a binary mixture. If we then what we're gonna do is JI equal to, we're gonna write CI into UI minus, we're gonna write Ci into u bar, molar average velocity for binary component, and we have defined it here too. For binary component, it is Ci C1 U1 plus C2 U2 divided by total concentration. So it's just gonna be so we have only two components, A and B, so it will be like Ca into Ua plus Cb into Ub. So it is individual velocities and individual values of their own concentrations, and here will be Ca plus Cb. Okay, so your Ci over here is the individual what we are talking about. So suppose we are talking about here is for component A, so we'll convert it by A. Here it will be A, and here it will be A. That's easy guys. So we have converted our formula for a binary mixture where two components are there. First is A and secondary is B, and we are finding the molar flux of A. Okay, and this thing is defined by Fick's law, sorry, Fick's law. Okay, so what he said, that Gi will be equal to this thing. Okay, that's pretty easy. Now tell me what we have defined. Ci to ui will be the Ni. So what will be Ca, because I is A here now, so Ca into u will be Na, right? So it will become just Na. That's gonna be easy, like minus. Now Ca upon Ca plus Cb is Ct, means concentration of A plus concentration of B will be give us concentration of mixture, and concentration A upon concentration of mixture will be just small fraction of A, and CaUA will be Na, and CbUB will be Nb. So now we have our, and what is J, which is okay, so that's we have replaced from the Fick's law. This is what we have done, so it worked very easily. So if you, for your exam, if you have to write the derivation like how it came, so it's gonna be very easy. How the Fick's law is defined, that like this, you have to just do a little effort, and you will reach this final formula. Okay guys, so we have this formula which is very important, and what it is relating Na. Now Na or Ni that we have defined over here, we have also told you that this Na is with respect to stationary frame. So okay, and Ja was with respect to molar average velocity frame. So Na is with respect to the stationary frame, Nb is the another component, and this formula is for binary mixture, right? This formula for binary mixture. So from here there are many cases, many types of problem are asked. So now we gonna look at application of this formula, and we will also look at some tricks to solve the problems easily. Okay, and we will also consider some nice conceptual problems based on these formulas. Okay, first of all, the basic equation just you need to remember is Na equal to Na plus Nb into Ya, or plus there will be minus Dab into dCa by dz. Okay, so this is gonna be the equation you need to remember first of all every time. Okay, so there will be cases of the solution. First case we're gonna take is the counter current. Okay, this case you will be here what you have to remember is that Na plus Nb will be equal to 0, and I hope that you know why it is so. Okay, the concept is Na equal to minus times Nb because both molecules are going opposite direction. Okay, so here it's gonna be very simple. You have to remember it like Na will be equal to just minus Dab into dCa by dz, and the formula, the first formula you will get here is Na equal, just integrate. So what you will get, Dab into minus and Ca2 minus Ca1. Why? Because the difference will be 2 minus 1, okay, upon dz. You can edit it, and it will be Dab into Ca1 minus Ca2, sorry for that, divided by z. And so this is the first equation for the counter current. But now I'm going to tell you a shortcut that you have to remember. So whenever you have three types of formats in which the question will be asked, because this thing which is concentration can be given in three forms. Ca, again, then is the form of pressure, which is the most important thing. Most of the time for the gases they will give in the form of pressure, and the third thing will be the mole fraction, which is also important. So the three things. Now you know easily this equation, you know easily remember, because just have to integrate. Even if you forget, just integrate. And so now when you have to go from this to this, you have to multiply with 1 by RT. Okay, and from here to here you have to multiply with total pressure. Okay, and just reciprocal, so 1 by Pt from here to here, and just RT from here to here. Okay, now let me tell you how will it happen. So suppose we want to write this concentration form here in the form of pressure. So how we can write in form of pressure will be Na will be equal to, now see, concentration is actually equal to Pa by RT. Sorry for that, I'm not looking at this. Okay, Pa by RT, that's why it will just become, as I told you, just multiply by 1 by RT. So it will be dV by RT Z, which is already there, okay, into just Pa1 minus Pa2. That's easy. Just multiply 1 by RT and you will pressure you will get. And again another, this third form will be just multiply it with total pressure. So it will be total pressure Dab upon RTZ into Y1 minus Y2. That's really easy. So this thing, so far so good. Okay, so that's how you have to remember this. Don't worry, I will share this the photograph of these knots. The handwriting is not very good, but the concepts are quite perfect. Okay, now so the second is the non-diffusing B case. Okay, so what will happen here, that the B will not diffuse, and the question will come, and the example for is, you have to remember, is absorption. So in absorption they will give you the that in the absorption column the rate is suppose given, then you have to remember this rate is based on the non-diffusing B case. So what will be rate, we will just remember the formula. But before that, go to the basics. So we know the basic equation, Na equal to y times Na plus Nb, and y is actually Ya, because the mole fraction of A component, because we are finding the rate of A. Okay, minus dab dca by dz. Mass transfer is one direction, and which is the z direction. It is really easy. Now put the Nb equal to 0, and when you will put it 0, what you will get, just transfer it here and you will get Na. Okay, so you will get, okay, just transfer after, you will get this thing, just make it like this. Okay, now Na will be equal to, what will transfer this dz over here, dz will come here, and here we'll have dca, so minus dab in. Okay, so this is what will you get. Now we know that ca equal to we know that y, basically what you have to remember, what is mole fraction, is the ca by ct. So we can make this in terms of y by just multiply divide the ct, and it will become, that's you will get. Okay, we have multiply divide with ca, so these will become y actually. So about that, this will become y. So this is mole fraction has become, okay, because you know this thing. Okay, so just integrate this, and remember there is a negative sign, and the one negative sign will come from here, from the integration, because the y is in minus. So what will cut down, and you will end up with dab into total concentration into what we'll get, limit will be from y1 to y2, so it will be 1 minus y2 upon 1 minus y1. Okay, that's you will get over here, and that's there was dz which will integrate to z, so we can transfer it here z, and that will your Na. So this is basic equation, most basic equation you have to remember, because sometimes we y1 y2 just take the ln. Sorry, here is the ln, I forgot. Okay, it's pretty easy, isn't it? So remember this equation. Now I'm gonna tell you a very important concept here. So if you look at what is 1 minus y2, and you know that we are considering only binary mixture over here, so there are two things, a and b. So if 1 minus y2 will be yb2. Okay, y2 is the mole fraction of a at the point 2, and it is also mole fraction of b at point 2. So we know that there are only two things, so their sum will be 1. Okay, that's a simple thing. So, and 1 minus y1 will be yb1. Okay, is it clear? So what is this thing? Actually this thing is nothing but ln of yb2 upon yb1. Okay, now just remember one thing. Okay, there is a thing called as log mean difference. Okay, log mean difference, what does it do? Suppose now we will define here the log mean difference of b component, yb component, so we will call it ybll. Okay, we call it like this. What it is, that it is yb2 minus yb1 upon ln of yb2 upon yb1. Okay, that's how it is defined. Okay, so from here, what is this thing? Just transfer it and get. Okay, just transfer and you will get this thing. Okay, now look at our this thing. This ln is actually this yb2 upon yb1 ln of, and we can replace it with this thing. So what will it become? You will get this thing. Okay, now I have a task for you. Put yb2 again equal to 1 minus y2 and yb1 equal to, okay, put this value in this equation and tell me what you get. I hope you have done it and you must have got this thing. Here y1 is actually ya1 because we are talking about the component a. So if you are finding an a, then there will be ya, ya2, yblm, which is another second component, ct. Now what is this total concentration? Okay, so there is the two things which you have to keep in mind. First, you are dealing with liquid. Okay, so same thing can happen with liquid also, suppose in given. Then the ct will be the average concentration, which you have to find with rho 1, which is the density of component 1 divided by molar mass of component 1, which will make it concentration of component 1, and rho 2 upon m2 and divided by 2. This thing you have to use. But for gases, you have to use ct equal to total pressure by RT. Okay, it's really simple. So put it here and you will get the formula, and now we'll find the another forms also. Okay, we have just derived this equation. Now this is in the form of y. Okay, and you must know what I have told you earlier about the how to go from CA to PA and to YA. You must remember that. Yes, you are right. This was this thing. Okay, we are here and we have to find the pressure. What will we do? This thing. But here in the case there is a little tricky part. You don't have to do this here. We will do it in the mass transfer coefficient. Here what you have to do is this. Okay, suppose you have to go for the sorry for that. Suppose now we have to go for pressure. So what you have to do, everything will be same, just change it to the pressure and make it PBLM. Okay, just change this thing will remain same. So it will become, yes, you are right, it will become this thing, PA1 minus PA2 upon PBLM, and this thing will remain same. Now here if you go for the concentration term, which is not much used, but for that case you can use this thing. Okay, you can use this thing. How you can do it? Just multiply it with the RT from here to here, multiply with the RT and keep it PBLM as well. So the RT will cut down, and what you will have? Yes, you will have this thing. So PBLM will be exactly same, just you have multiplied it with the RT, so RT will be cut down from this rule, this thing, and you will have this thing. So we have got our three formulas which you have to remember, but conceptually remember. So you don't actually have to remember them. You can derive every time if you forget. Okay, that will help you for your get.